All right, so starting up the second day of antiderivatives, we're really going to look at, rather than calling them antiderivatives, we're going to look at the integral and how we can integrate certain functions. So anti-deriving something and integrating are kind of the main things. If you look at the day 2 notes, I'm going to be going through a couple of these problems to kind of hopefully make some things a little bit easier for you. And I'm going to start with this first one. So if we're finding the antiderivative, so if we just have f of x, so we're not always going to call it y prime or f prime if we're going to antiderive something, but you can always think of it that way as you go through and do it. So if I want to antiderive something, what that means is that's the same thing as if I wanted to integrate. So this sign, okay, means just basically to integrate. Okay, and if I want to integrate f of x, I want to do it in terms of dx. So that this just means similar to what we did when we were deriving. We derived it with terms of x. So this dx basically is saying we're going to integrate with terms of x rather than with terms of y or t or whatever other value that we're going to be looking at. So this is the same thing as if I integrated x to the 1/3 times 2 minus x squared dx. And so if I'm looking at integrating this, well, what we're going to be looking at today is we're still going to be looking at the step-up rule, and then also we're going to be looking at how we can integrate both trig functions and log functions, exponential functions, things like that, but very basic ones. So if you remember when we started off derivatives, we didn't actually do this because we knew how to do the chain rule and the product rule after, but when we first started, what we actually did was we actually multiplied this out. If you multiply this through, what you end up getting is you end up getting 4x to the 1/3 minus 4x to the 4/3 plus x to the 7/3. And that just comes from, so this is dx, so this is all kind of grouped together. Okay, so where that comes from is this 2 minus x squared up here. That's just equal to 4 minus 4x plus x squared, and then you multiply them all by x to the 1/3 to be able to get this. So now if I'm looking at what this is going to be, this by the step-up rule, we take that 4x to the 1/3 and we step it up a whole value. So this would be 4x to the 4/3. And then rather than when we derived it and brought it down and multiplied, what we're going to do now is rather than multiplying is you divide by what your exponent is. So divide by 4/3 minus 4x to the, now this is going to be 7/3. And now this is going to be divided by 7/3 plus x to the 10/3, stepping up, divided by 10/3. So whatever you step up to here, that's going to be what your denominator is. Don't forget your plus c, where this is, remember, your constant, because if we went through and we wanted to work backwards and we wanted to derive it, this c would go away because it's some constant. So just always remember that plus c. There, especially the AP and IB tests, when you go through next year and take those, if you forget that plus c, you'll probably lose a point here and there. So just kind of make sure that you always remember it as you go through and do it. And as long as you're not given a point, you just kind of leave it as plus c, and that'll be in your answer. So this is really just equal to, then, this is going to be 3x to the 4/3 minus, what's that going to be, 12 over 7x to the 7/3 plus, that's going to be 3 over 10 x to the 10/3 plus c. And then, so this is going to be, right, the antiderivative of our first initial function, and this value up here. So if you wanted to check, all you have to do is you just have to take this function right here, and then just, if you derive it, you should get what that original function is. And if you kind of look more so at it, it should be more so what this function is as you go through and do it. All right, so that's kind of the first problem, but that's just mostly looking at the step-up rule, which kind of helps out a little bit more. Okay, if we look at the next one, I think this one's a pretty good one. So if we look at integrating, or looking for the antiderivative of 2 over x plus 3e to the x dx. Okay, so as I'm looking at and doing this, what you can do is you can actually split these up. So this is the same thing as the integral of 2 over x dx plus the integral of 3 e to the x dx. You could probably hear my daughter in the background screaming because she's excited about integrals as well. So what you can do is this 2 is just a factor and it's a constant, so you can just kind of bring it out front. So then we're just integrating 1 over x dx plus 3 times the integral of just e to the x dx. So you can take out these constants out front, which makes it easy because if we think of the antiderivatives of the natural log and e to the x, you get 2 times the natural log of the absolute value of x. Remember I spoke yesterday about how this and why this was the absolute value, because you can plug in anything for x here, positive or negative, so we have to be able to plug in anything for x here, positive or negative. You can't plug in 0 here, well you can't plug in 0 here as well too, so that kind of works. Plus 3 times the antiderivative of e to the x, well that's just e to the x, and then plus c. You don't need a plus c for both of them, you just need one plus c at the end, and this would be your antiderivative. If you went through and you actually derived it, what you would get is you would get this 2 over x plus 3 e to the x. Okay, and then the last one I'm going to go through is, where is it at? It's this one, it's about 4 or 5 pages down, I think it's page 5. If we're looking at the integral of -1 over the square root of 4 minus x squared. Okay, this one's a little bit tougher because this is a trig function one. If you can notice and remember what trig function this looks like, well this looks like an inverse derivative. So if you remember the inverse derivatives, so remember the sine inverse of x, if we derive this, we ended up getting 1 over the square root of 1 minus x squared. If you derive the cosine inverse of x, you get -1 over the square root of 1 minus x squared. And if we derived the tan inverse, what we got is 1 over 1 plus x squared. So we got these three are just, they're ones to remember as you go through and do these. The ones that we use the most is probably the tan inverse. In this case, if we look at which one this kind of looks like, the main reason why I think it's the cosine inverse is because this -1 on the top. So we're going to think about it in terms of the cosine inverse. The only thing that's a little bit different is that we want it so that this value right here is 1. This value is a constant, it has to be 1. So we need to make this value 1 as we go through and do it. So how we can do that is we can look at making this -1 over the square root of, well, if I want that to be a 1, then you just have to factor out a 4. You factor out a 4, you're left with 1 minus, and this is going to be x squared over 4. Okay, so then this would be equal to the integral of -1 over 2 times the square root of 1 minus x squared over 4. Okay, but the big thing is that we need something here, we need something squared. So we need to figure out how we can get this to be something squared. Well, if we look at x squared over 4, that's equal to what squared? Well, that's equal to x over 2 squared. So I can just change this to be 1/2, if I take out this 2, times the integral of -1 over the square root of 1 minus x over 2 quantity squared. Okay, so then when I look at that, how that deals with this, well, this is still just a variable just like this is, so I can just say that this is equal to 1/2 times the cosine inverse of x over 2. Okay, the only thing that's a little bit different here is that now it looks like we would have had the chain rule in this case. So if here's kind of a quick introduction to this. You didn't have to do this on your homework, but it's a good introduction to what we're going to get to, is that if we are using the chain rule here, what we would have to do is we would have to multiply this function by 1/2, okay, if we use the chain rule. So if we're using the reverse chain rule or working backwards, what you would have to do is you would have to multiply this function by 2. So what you would end up getting is just the cosine inverse of x over 2 plus c, because this 2 and this 1/2 end up canceling one another. And then this will be your answer. So that one's a little bit tougher, but I did include it here because it's a good introduction as to what we're going to be doing in the future. So just as you go through and do this, please ask any questions as you go through and look at it. I know this last one was a little bit difficult, but the problems that are on the worksheet shouldn't be this tough as you go through and do it. But please let me know if you need anything. And other than that, you guys have a good day, and I will talk to you guys